So, what we'll be doing in today's class, basically, I'll be highlighting the process of econometric analysis. And once this process of econometric analysis is discussed, then I'll be focusing on what topics we are going to cover in this course. Now, when we talk about econometric analysis, as someone was pointing out, we start with economic theory. Like if I talk about regression analysis, I use some data. There would be one dependent variable. There would be a few independent variables. And I'll basically focus on estimating the model and carrying out testing of hypothesis. In econometric analysis, we'll discuss some issues, some aspects beyond that. To begin with, we should have some understanding of the underlying economic theory. Basically, I'm talking about this step. For example, I may aim at testing the validity of the Marshallian law of demand. We all know the Marshallian law of demand. Now, question is, while examining or testing the validity of Marshallian law of demand, what type of framework I'll be using? You have studied in economics that when we are discussing about law of demand, to begin with, what we assume? We assume that quantity demanded for a commodity varies with its price. Other things remaining the same. The moment you switch over from Marshallian framework to say indifference curve analysis, there we discuss about the change in demand as well. Demand for a commodity may change because of change in income of the consumer, because of change in prices of other commodities, etc. So this analytical framework is very, very important in econometric analysis. So when we go for econometric analysis, we start with some discussions on the underlying theories. Like say, if I talk about consumption function, dependent variable is consumption expenditure, independent variable is income, That is what we discuss in simple Keynesian model. But as you go for further discussions or further analysis, you might have seen in your macroeconomics courses, we say that consumption of ERT may also be a function of consumption of ERT minus 1. Consumption can also vary with rate of interest. There are many such developments in the economic theories. And bringing in some such developments into the model would be very, very important. So we need to have clarity about the underlying economic theories, because based on that, we'll be defining the mathematical model as someone was pointing out. Let me tell you, when I say defining mathematical model, it's not simply about writing y is equal to mx plus c. Definitely, that part is important. I mean, basically, writing or expressing an economic theory in some mathematical form, that is definitely important. But at the same time, it may be very much contextual. Let me give an example. Suppose I want to test the validity of the law of demand. So say y stands for the dependent variable, that is demand, and x stands for the independent variable, that is price. Now I can write two specifications. I can write yi is equal to alpha plus beta xi plus ui, and I can test if the slope, that is beta, is statistically significant and negative. If so, then the law of demand is valid. Again, someone else may write yi is equal to alpha plus beta by xi plus ui, and may test the hypothesis that beta is positive. It is statistically significant and positive. Now, in both the cases, if say, for example, in the first case, beta is statistically significant and negative, then we are saying that the law of demand is valid. In the second case, if I find beta is statistically significant and positive, then also the law of demand is valid. Because in both the cases, we are getting an inverse relationship between price and demand. But then which form to go for? As I said, it is contextual. Though in both the cases, we are getting an inverse relationship between X and Y, the functional form is not the same in both the cases. In the first case, it is linear. In the second case, it is nonlinear. That's what, when we talk about mathematical model, it is not simply expressing economic theories in some mathematical forms. It is much beyond that. And when I say this, I would basically highlight three very, very important aspects. One is the set of explanatory variables, like whether it would be Y versus X, or it would be Y versus X1, X2, X3, X4, like that. What would be the set of explanatory or independent variables? Like one can write demand as a function of price of the commodity. One may also write demand as a function of price of the commodity, prices of the related commodities, income of the consumer, etc. In fact, we have studied both in economics. So, what should be the set of explanatory variables to be considered? Second is instantaneous versus lagged relationships. Again, this is very, very important. A change in the independent variable or the independent variables may not have immediate consequence on the dependent variable. There may be some time lag. You have studied in economics, particularly in case of theory of consumption, that if income goes down, consumption expenditure may not be adjusted immediately. It may take some time. There are many examples in economics where there may be lag relationships between the dependent variable and the independent variable or the variables. In fact, there is a specific domain in econometric analysis, that is the analysis of dynamic models. It's very, very important component. And from these dynamic models, we can switch over to time series analysis. Of course, we'll have detailed discussions on that in the next semester, that is in the course Econometric Analysis 2. But while discussing during the course in this semester also, we'll be having some references on dynamic models. But as I said, instantaneous versus lag relationship, I mean, that sort of specification would be very, very important. It has in fact many purposes. Like in many cases, we use the lag basically to set the direction of causality. For example, while consumption can influence income, income can also influence consumption. So there may be a bidirectional causality between consumption and income. So one may also write, while estimating a consumption function, one may also write that Ct is a function of yt minus 1. Consumption in year t as a function of income of the last year. It's a lagged relationship. It may so happen that if income increases, consumption may not increase immediately. But then beyond this conceptual issue, there is another advantage. That is setting the direction of causality, whether income is influencing consumption or consumption is influencing income. Having a specific direction of causality is very, very important in econometric analysis. Otherwise, there would be simultaneity bias and hence some consequences on the regression coefficients. Again, that part we will be discussing in the next course. Now, what happens here when I'm writing Ct as a function of yt minus 1? Obviously, I'm setting the causality from yt minus 1 to Ct because past value can influence the current value. Means past income can influence current consumption. But current consumption definitely cannot influence past income. So here actually we are ruling out the possibility of the direction of causality from Ct to yt minus 1. You have studied in economics, in particularly in macroeconomics, how increasing consumption expenditure can influence income level as well. So the simultaneity bias, bidirectional causality is very likely. So when we write Ct as a function of yt minus 1, actually we are ruling out the possibility of the causal relationship from Ct to yt minus 1. Because current value cannot influence the past value. So while expressing the economic theories in the form of mathematical models, we need to be concerned, or we need to be very, very careful about this sort of issues, that whether the relationship would be instantaneous or there would be some lags. And the third one is, of course, the functional form, as I discussed sometimes back. That whether the relationship is linear, or it is log linear, or it is quadratic, or it is cubic. That is one aspect. But the other very important aspect is inclusion of the intercept. An obvious question, I often ask this question, that if the theories don't permit, if the data set doesn't support, do we still need to have an intercept into the model? Is it necessary that always we should write yi is equal to alpha plus beta xi plus ey? What is the role of intercept in regression analysis or econometric analysis? Of course, in economics we have an interpretation. In economics we have an interpretation. For example, short-run consumption function. There the vertical intercept stands for autonomous consumption. But what happens in case of long-run consumption function? So these are some of the fundamental issues we need to be very, very careful about while expressing the economic theories in mathematical forms. Next, very, very important question is basically here. When we talk about defining the set of explanatory variables in a regression model or econometric model, how to decide on that? One is definitely the theoretical support. What we study in theory, based on that, we define the mathematical models. But often we may also be constrained by availability of data. Let me give an example. We know that demand for a commodity depends on price of the commodity, prices of the related commodities, income of the consumer. But at the same time, we have also studied that demand also depends on consumers' taste and preference, consumers' expectation about the future price. Now, I may be interested to add these variables because I have studied. I know that these variables may be very, very important. But I may not be in a position to add these variables into the model because I don't have the data. Again, it may so happen that I have studied some aspects in theories, but experiences may also matter. From experiences, particularly those who carry out primary survey. In fact, I have done extensive fieldwork in different projects and during my research. And during your field experiences also, you may learn certain things and you may see some new variables that may be very, very important. Like say, which crops farmers would like to cultivate. We have seen in the field that there are certain issues, certain aspects that are beyond the theories. Some social dimensions, some demographic issues, which may influence farmers' decision of crop choice. We have seen sometimes the crop choice may differ depending on the age of the household head, or depending on whether the household head is male or female. What I'm saying, there are certain standard theories, but if one carries out primary survey, visits the field, one may get many important insights, and then combining the theories and the experiences from the field, one may define the mathematical model, which variables to be included into the model. And accordingly, the hypothesis may be set. Again, this aspect is also very, very important. Data availability and measurement of the variables. Like I'm asking you, how will you measure financial performance of a farm? Can anyone tell me how to measure financial performance of a farm? What indicator would you like to use? Hello? Hello?
Yes, sir.
So can you tell us, I mean, what indicator would you like to use to understand financial performance of a farm?
Like cost of resources and total sales.
The financial performance may be in terms of, I understand that those who are in second year in particular, you might not have done any course on finance. It may be in terms of say profitability, or say returns on capital employed, or say returns on assets, etc. There may be alternative proxies, alternative measures of financial performance. Now let us take the example of profitability. When I say profitability, we basically measure it as profit by sales. Now what type of profit we should use? If you see the financial statement, it may be profit after tax, it may be profit before tax. In fact, in our lab classes, we'll be using some data sets where we'll be using both the measures of profit. Now, say for example, you are interested to add one variable, that is profitability. Now, whether you would be measuring profitability as profit after tax by sales or profit before tax by sales, that depends on whether you have data on profit after tax or profit before tax. If you have data on both, you can use both and see the consistency of the results, and you can say subsequently that no, my results are not sensitive to the measurement of the variables. So what I'm saying, how I would measure a variable availability of data. If I have data on both profit after tax and profit before tax, I can measure profitability as ratio of PAT, means profit after tax to sales, as well as profit before tax to sales, and I can use both in alternative models. And I can see if the results are consistent. Again, measurement of the variables would have another dimension, that is changes in origin and or scale of the variables. To what extent they can have implications for the findings. While discussing in subsequent classes, we'll be focusing on these aspects, not only theoretically, but also in the lab classes, we'll explore how the regression results may change, if any, depending on changes in origin and or scale of the variables. How the regression results may alter depending on measurement of the variables. How regression results may change depending on whether you are introducing lags or not, depending on functional form. All these issues would be discussed in detail during this course. Now, once mathematical model is set, we'll convert it into statistical model by adding the random disturbance term. So when I'm going for testing the validity of the law of demand, I'm writing yi is equal to alpha plus beta xi. That's the mathematical model. And then I'm adding ui, and then this mathematical model is converted into statistical model. In mathematical model, we don't add the random disturbance term. Right? When we add the random disturbance term with the mathematical model, then it is converted into statistical model, because we assume we make some assumptions about the statistical distribution of U. What do we assume? Again, we'll be discussing on that in detail. But many of you might be knowing, we assume that this random disturbance term is normally distributed with zero mean and constant variance. We also assume that for successive observations, this random disturbance term is pairwise independent. We also assume that this random disturbance term is independent of the explanatory variable or the variables. So there are certain assumptions about the random disturbance. Now the bigger question is, of course, why do we need to add the random disturbance term into a statistical model? Into a mathematical model, to convert it into a statistical model? Because it is very, very important, because often we commit some errors. And this random disturbance term is added into the mathematical model to capture such errors. A very simple explanation or example of some such error may be the measurement error. We may not be in a position to measure the variables appropriately, and we may commit some errors in the process. Like say specification errors. We may not be in a position to define the exact mathematical form or the set of variables to be added in the model. So there may be various errors that we may commit, and it is expected that the random disturbance term would capture these errors. But interesting part here is that there may be possible violations of the assumptions of the random disturbance term. So I'll discuss in detail what are the assumptions that we make about the random disturbance term and what may happen if these assumptions are violated. I'm not going for detailed discussions about this part right now. But surely these aspects are very, very important. And we'll have specific discussions on these aspects. What we'll do in this course, we'll discuss about estimation of the models. We'll discuss about testing of hypothesis. I'll go for that. But we'll also have very, very detailed discussions about possible violations of assumptions on the random disturbance term and what may be the consequences. But this part will come little later. What we'll do in this course, we'll basically start with some aspects of economic theories, then defining the mathematical model, then going for statistical model. Here, we'll be basically focusing on, to begin with, why to add the random disturbance term and what are the assumptions and what are the possible consequences if these assumptions are violated. And we'll stop there to begin with. But as we proceed, subsequently we'll be discussing in detail on these possible consequences. Particularly, we'll be focusing on heteroscedasticity and autocorrelation. Then this part is the core. Basically, estimation and testing of hypothesis. There are several methods, like say method of OLS, method of maximum likelihood estimation, method of moments. But in this course, our focus would be mainly on the method of OLS. And to some extent, we'll be discussing the method of MLE. But as I said at the beginning, at each and every stage, your understanding of hello. At each and every stage, your understanding of statistical test, the fundamentals about the statistical test would be very, very important. What type of statistical tests will be carrying out? I'll start with this, the last one. We need to see the statistical significance of the overall model, the estimated model. At the beginning, when we carry out statistical test, at the beginning we'll be seeing if the estimated model is statistically significant. Then we'll be looking at the goodness of fit, what basically we see in terms of R square value or adjusted R square value. And then we'll be seeing the statistical significance, sign, etc. of the individual coefficients. Now, while discussing the results, particularly in terms of testing of hypothesis and the interpretation of the findings, these two components I'm talking about, three things are very, very important. One is if there is any relationship at all, then what is the nature of the relationship and what is the extent of relationship? Because based on these three, subsequently we will be drawing some implications for policies and strategies. Right? When we do econometric analysis, this is a very, very important objective. That what insights do I get from the econometric analysis? What implications can I draw for designing policies or designing strategies? At the same time, in econometric analysis, of course, it is true in regression analysis also, I would be focusing a bit on the potential limitations of what you have done. This is very, very important knowing what I have done and what I couldn't do. I'll be giving you some examples later on. You will see different aspects of the regression results look absolutely fine. But then I'll raise certain concerns. So while carrying out econometric analysis, in addition to what I have done, it is also important to highlight what I couldn't do, maybe for various reasons like data limitation, beyond the scope of a particular work. It is possible. It is possible that there will be certain limitations of what I have done. But what is very important here is not the limitations per se. Understanding the limitations and recognizing the same. These two are very important. So this is the overall approach. Of course, sorry, just one more aspect I forgot. This loop is very important. While carrying out econometric analysis, after we estimate the model, we need to test for validity of the assumptions. If the assumptions are valid, we can go ahead for interpreting the results, carrying out further analysis. But if the assumptions are not valid, then we need to apply certain corrective measures, and for that we may also need to re-specify the model, and we may need to estimate the model again. So what we basically do, from economic theories we define the mathematical model, then we convert the mathematical model into statistical model. We gather data, measure the variables, estimate the model, then we test for validity of the assumptions. If the assumptions are valid, we go for further analysis. If the assumptions are not valid, then we apply certain corrective measures, and for that we may need to redefine the model, and we may need to definitely the moment we redefine the model, we need to estimate the model again. But as I was telling, this last part would be very, very important in econometric analysis. That is, in addition to carrying out testing of hypotheses, we'll be focusing on interpretation of the results and drawing some implications and recognizing the limitations of what we have done. Okay, so with this, I'll stop for a while and I'll take your questions.